Okay, all right. Good morning, everyone. Okay, so this is the second video for the revision practice paper. All right, so we are going to carry on from question 11 all the way to 16. Okay, so for this part is more of a salt preparation. As you can see from the questions, so I have some revisions on the oxides, and then yeah, again more salt preparation. Okay, so we are going to carry on with question 11. Okay, so for question 11, okay, we have calculate the mass and volume of ammonia which will be produced from 370 gram of calcium hydroxide. Alright, so what we have here is 370 grams of calcium hydroxide. Okay, we are supposed to find both the mass as well as volume, okay, for ammonia. Okay, so what I can first thing I do is this, because I'm given the mass, I need to find the mole, mass to mole. So that's step number 1, divided by the MR, mass mole MR. Okay, then subsequently I use the mole ratio, which I identify using the numbers here. If it's nothing means 1. Down here is 1:2. The ratio 1:2. So you multiply by 2. Okay, 1:2 you will multiply by 2. Okay, to get the moles. Okay, so yeah, so to get the, so step number 1 is get 370 grams. Okay, then go to mole by dividing by MR. So step number 2, using the mole ratio, okay, 1:2, 1 units to 2 units, you multiply by 2. Right, then subsequently from mole to mass, okay, you multiply by MR. Okay, and then secondly from okay, now if you want to get the volume, okay, we need to put in the other formula, which is this one. Okay, from mole is a gas, okay, take note it's an ammonia gas. Right, question has stated ammonia gas, or otherwise the state symbols will be given. Right, so in this case it's ammonia gas, so I multiply by 24 to get the volume. Right, okay, so this one I multiply by 24 dm cube to get the volume. Alright, so I'm going to do step number, okay, so this is step number 1. Step number 2, mole ratio. Step number 3, mole times MR of ammonia to get the mass. And then the fourth thing I do is mole times 24 to get the volume. Alright, so there's 4 different steps I do. Okay, step number 1. Okay, I do a mass over MR of calcium hydroxide, that is 74. Okay, so I'll get 5 moles. Okay, then using a mole ratio of 1:2, 5 times 2, so I get 10 moles of ammonia gas. Okay, so that's my step number 2. Step number 3, I'll find the mass. I take the mole multiplied by the MR as discussed earlier. Mole is 10, MR is 17, so 170 grams. Yeah, 170. Okay, and coming to step number 4. Okay, I can use the mole, which is 10 also, multiplied by 24. So I get 240 dm cube. Okay, right. So, and there you go. Okay, I'm done with question 11. Okay. Right, so for question 12, okay, use the following information to suggest steps to prepare by precipitation pure lead-2 sulfate. Okay, So what we have to do is starting okay, from lead 2 oxide. Okay, so you are told certain information like lead 2 sulfate is insoluble. Okay, so definitely prepare by precipitation where you start with 2 solutions. Okay, so how you know? Okay, you can go back to the summary notes under salt preparation, precipitation. So this part, okay, precipitation will start with 2 solutions. Okay, so for example, in the question we have your lead 2 sulfate. So this case you start with 2 solution. One is something nitrate, the other one is something sulfate. Okay, or otherwise sulfuric acid also can. Okay, so this one you put the first word here, lead 2 nitrate. The other one you can put something like sodium sulfate. Okay, any sparse salt or otherwise potassium sulfate or even ammonium sulfate. Right, that's what you can do. Okay, let's go back to the question itself. Okay, this one maybe let me guide you through. Okay, right, okay, let's take a look. Okay, so you need to have two different things to work out. Okay, so okay, so normally what you do in N level is that you have lead 2 sulfate. As advised earlier, one is nitrate, something nitrate plus something sulfate. All right, okay, you must start with 2 solutions. So this is solution 1 and this is solution 2. Okay, so this is lead 2 nitrate, the other one is perhaps something like sodium sulfate. Okay, this will definitely make it a solution because your spent salts are soluble. Okay, all these spent salts, yeah, are soluble, right? Okay, so going back, okay, but the thing is you have to start with lead 2 oxide. Okay, so the first step would be creating one of these 2 solution, lead 2 oxide plus something, okay, then gives you the lead 2 nitrate. Right, okay, so this part is involving adding excess because you are told lead 2 sulfate is insoluble. Okay, meaning to say it will be a solid. Okay, it will be a solid. You're adding excess solid to acid. Okay, so this will be like a hybrid between 2 salt preparation method. Okay, so adding excess. All right, whereby the carbonate base or reactive metal with acid All right, okay, so yeah, the steps are all here. Okay, let's go back to the question itself. Okay, so to think of the acid, okay, you want lead 2 nitrate. So this part will tell you about the acid, the second word. Okay, so this will be nitric acid. Okay, dilute nitric acid. Okay, then of course you get other things which are not so important in this question. Okay, water, yeah, water. Okay, it's an acid plus base reaction. Okay, although lead 2 oxide is amphoteric oxide, but it acts as a base in this case. Right, okay, so you have to add excess lead 2 oxide into the acid to get the lead 2 nitrate first. Yeah, in this case. So what you do is this. I say this is the nitric acid, and you just add lead 2 oxide inside. Okay, a lot of lead 2 oxide inside. Okay, then next thing you do is to filter out. Okay, the lead 2 oxide Okay, then you get lead 2 nitrate. Okay, so this is lead 2 nitrate then you use this for the subsequent reaction Okay, so this is lead 2 nitrate Okay, then you add in your sodium sulfate as discussed earlier. Okay, so maybe I zoom out so you can see the whole thing. Yeah, then you will get the lead 2 sulfate. Then you must go and filter out Okay, so it's a hybrid of the two methods just that this part you don't go and do the heat to saturation. This part is the adding excess. Okay, then this part onwards okay, you get the this lead 2 sulfate area is a precipitate then you can do filtering. Okay, you can filter out okay, then this is what you want. Okay, inside the filter funnel one, this one your lead 2 sulfate this is what you want okay, then normally you take it out, you wash with cold distilled water. This thing is your cold distilled water. Okay, so it's a hybrid of the two methods okay, so this part is the precipitation method. Okay, so I'm using sort of like two methods mixed in one okay, so this will be a tough one. Okay, quite special. Okay, so let's try to fill in this blank. So you add excess lead 2 oxide okay, so this one is a solid into the nitric acid. Okay, then after that you filter to remove excess lead 2 oxide as the residue. Okay, but yeah, this one you're interested in the filtrate you're interested in this one. Then you add sodium sulfate okay into your filtrate and then after that you will get the precipitate already of lead 2 sulfate. Then you filter to remove okay lead 2 sulfate as the residue. Okay, so now you want the residue, this one is a residue. Then you wash with cold distilled water and pat dry with cold distilled water and then pat dry between pieces of filter paper. Right, okay, so these are the different steps involved in this question itself. Yeah, okay. Okay, let's look at the next question. Okay, so next question also another O-level questions. So there's a couple of O-level questions here are the tougher ones just to stretch you and let you have a feel okay of how is it different from N-level questions? Because acid bases salt are things you learn actually in N-level, but the questions are slightly different. Okay, requires you to write actually a bit more than what you are normally used to at N levels. Yeah. Okay, let's take a look at this question. Okay, so state two substances when mixed together will form a precipitate of a calcium carbonate. Okay, so same thing. Okay, we start with two solutions. Okay, let me erase this. Okay, because it say precipitation. So it is back to the same old thing lah. Okay, you start with two solutions. Alright, for precipitation. Okay, one is a nitrate, the other one a spa salt lah. Alright, start with two solutions. Okay, let's back to this. Okay, let's have a look. Okay, so this is calcium carbonate. Okay, so you have one is a nitrate. Remember, that's what we say earlier on. The other one is something that contains carbonate okay, a solution that contains carbonate. Okay, so it will be sodium something, right? Sodium something. Okay, so the cation okay, the metal follows the nitrate, and then this one follows the sodium, right? So two substances can be calcium nitrate and sodium carbonate. Right. Okay. Otherwise, actually, this is the white precipitate you get in your lime water. This is the white PPT okay, in the lime water one that you normally see during your QA. So what you can do is, you can also write carbon dioxide and lime water. No, lime water is actually calcium hydroxide. Right, calcium hydroxide. This is actually your lime water. Okay, so what three processes will you use to obtain a pure sample of calcium carbonate from the result of this mixing? Okay, is right. So what you do, this one is a direct precipitation. So first thing you do is add solution 1 to solution 2. So now you know what is the solution 1, what is the solution 2. I will fill it in. Okay, so solution 1 is your calcium nitrate. Okay, and then solution 2 is your sodium carbonate. Right, then after that you filter to remove so over here will be what you want, which is your calcium carbonate. Okay, so this part you do your filtering. Alright, this part you do your filtering. Okay, then you wash with cold distilled water. Okay, so you filter to remove calcium carbonate and residue. Wash the precipitate with distilled water or cold distilled water. Then after that, pat dry. Okay, so this one is a pretty simple one. Direct precipitation. Right, direct precipitation. right? Okay, then with that I shall proceed to question 14. Okay, question 14 I think is a question on adding excess solid to acid. Okay, how I know? Okay, let's look at the question. You have to prepare a sample of copper 2 chloride crystal. Okay, so this one okay, if you check the solubility of chlorides okay, is this okay, let's look at the solubility first. Okay, so solubility of this okay, all chlorides soluble except for these two. Okay, so if it's copper 2 chloride, it's actually soluble okay, let's go to here. Copper 2 chloride is actually soluble okay, go back to the question. Right, so this one is a soluble salt. Okay, then how do I decide? Okay, if it's okay, so if it's soluble salt but it's not a spa salt, so not the spa salt so you actually use adding excess uh solid to acid. Okay, for example, okay, I'll give you one example. Let's say you want to prepare zinc nitrate. Zinc nitrate is a soluble salt that's not spa. Okay, what you can do is you add it into acid. So the second word tells you about the acid, the first word tells you about the metal, the base, or the carbonate. Okay, this one is to let you know you don't have to copy down first okay, so let's say you want zinc nitrate, you start with either zinc, the acid would be nitric acid, nitrate salt from nitric acid. Okay, if I want sulfate, then I use sulfuric acid yeah. If I want chloride salt, then I use hydrochloric acid. Okay, so I have zinc as the solid. Okay, then base is oxide or hydroxide zinc oxide or zinc hydroxide. Okay, so a base is a oxide or hydroxide, or otherwise zinc carbonate. Right, okay, so all three also can in this case. Right, okay, so back to what we do just now. Okay, if you want copper 2 chloride, okay, what you can do is this okay, the second word tells you about the acid remember. Okay, so it's chloride salt. Okay, you will use hydrochloric acid. Right, okay, then this method is obviously adding excess solid to acid okay, excess solid to acid. Okay, because it's a soluble salt that is not spa, right? Not spa salt by spa I mean sodium, potassium, and ammonium. Alright, okay, not spa so your copper 2 carbonate is the solid they use, added to 100 centimeter cube of warm acid, so the gas given off, and then when the reaction has stopped, the mixture was filtered and then reduced to half its volume by heating. So this part is the heat to saturation okay, so basically this part is telling you about the heat to saturation. Okay, how you know? Here. Alright, so this is the steps so this part, heat to saturation, is usually 1/2 of original volume. Okay, so look at the steps on page 13 of your summary notes. Okay, here. Alright, then the remaining solution was allowed to cool, crystals was formed, were filtered off, washed with cold distilled water, and so on. Right, okay, so you can match all these steps with those on page 13. Right, okay, so then you should see that this method belongs to adding excess solid to acid okay, back here. Okay, so which chemical was added in excess? Okay, must be the solid. Okay, which is the copper 2 carbonate, this one. This one is the solid. Okay, this is to ensure all the acid had reacted. Okay, once again I mentioned this in the summary notes. Okay, what you do is go back here, have a look. Okay, how come you need to add excess is to ensure all the acid has reacted so that salt is not contaminated with acid. Okay, adding excess of the solid. Okay, back here. Okay, so that salt is not contaminated with acid, right? Okay, so the next part is this, okay, how could you tell that the reaction had stopped? Okay, okay, so the reason is this, okay, how could you tell that the reaction had stopped is this, okay, so basically you notice that the gas was given off. Okay, so there's two ways to see lah, because you're dissolving a solid, right? Okay, you're dissolving it into the acid in this case is the HCl, hydrochloric acid. Then you throw in the copper 2 carbonate, then there are bubbles coming out Okay, so two ways to tell is that you don't have bubbles anymore, or the other one is there's no more copper 2 carbonate. Okay, can dissolve. Or there's no effervescence produced. Effervescence means the bubbling. Right, okay. And then why was the filtrate heated to reduce its volume, okay, by half? Okay, so this is the part is to create a saturated solution, to obtain a saturated solution. Okay, very simple for this part okay, and then it's a acid plus carbonate reaction. In this case okay, you have the acid, you have the carbonate. Acid carbonate ACCSW gives you carbon dioxide, salt and water. So the gas that they are talking about is your CO2. Okay, all right, and how do you actually test for it? Okay, it's given inside your summary notes. Okay, over here test for CO2. Okay, this one you should know since you do a QA. Okay, bubble through lime water, white precipitate form, right? Okay, so let's write the observations for this question. Name of gas is carbon dioxide. Test is bubble the gas into calcium hydroxide. Right, and then the observations is that white precipitate will be formed in the lime water. Yes. Okay, so the test for the gases, you can have a look okay, I'll cover more in detail in QA. Okay, we'll revisit this part when we do the next chapter on qualitative analysis. Right, okay, and then you can have a look okay, hydrogen gas, oxygen gas, as well as ammonia gas. Okay, so the reactions that produce ammonium salt plus alkali, right, it gives you this one actually gives you ammonia plus salt plus water. Ammonia plus salt plus water right? Okay, so the four reactions okay, don't forget the acid bases reaction like ammonium salt plus alkaline again. Okay, then acid plus carbonate, and then reactive metal plus acid okay. So the four reactions, do recall them in your summary notes page 4 and 5, as well as the test for gases on page 9. Yeah. Right. Okay. So now let's write a chemical equation for this with state symbols. Okay, so let me have a look Right. Okay, so I shall write the word equation first. Okay, let me see. I shall write the word equation first for this part. Okay, word equation. Okay, so you have copper 2 carbonate. Then I build from there. Copper 2 carbonate plus the acid is hydrochloric acid. So it gives you copper 2 chloride plus carbon dioxide plus water. Okay, you zoom out a bit high. Plus water. Okay, so how do I know it's copper 2 chloride? Because second word comes from the acid, first word comes from the copper, right? Okay, can. Okay, so copper 2 carbonate plus hydrochloric acid so what's the formula for acid? Is all acids have H plus, then remember your chloride okay, so you got to still recall okay, in terms of the formulas there okay, so HCl aqueous. Okay, because it's same charge this case, same charge, I write down 1:1. Okay, that means HCl. Okay, if it's later on something like different charge one okay, I write short form like copper 2 chloride you have Cu2 plus the 2 means the charge is 2 plus. This one gives you the charge, okay, and then this one is Cl minus. So this case I need to do crisscross. Okay, I put down Cu, I put do Cl, so CuCl2 the 1 comes here, the 2 comes here. So this one is CuCl2. Okay, soluble salt, so aqueous. Okay, remember this salt is actually soluble. Okay, and plus carbon dioxide gas as well as water. Okay, so I will try to balance based on this formula. So I got 2 chloride, 1 Cu2 plus. Okay, then 1 Cu2 plus and 1 carbonate down here. Okay, so it's obvious. Okay, I need to do something regarding this chloride. So I need to have 2 sets of HCl to balance this. Okay, chloride balance, copper balance. Okay, then I will have the CO3 usually will becomes the CO2. Okay, losing one oxygen go to the water. Okay, so you can try to trace this way: CO3, CO2 then the remaining oxygen, then the 2H comes out in H2O. Alright, so then this equation is balanced already. Alright. Okay, then let's look at oxides okay, so to do a quick recap on oxides, okay, I'm actually copying out this flowchart from page which page okay, under oxides here, page 5 of your notes under oxides. Okay, so basically oxides okay, I have 4 types okay, under metals I have basic and amphoteric. Okay, so they react with the acids and bases for amphoteric. There's 3 of them ZAL or ZAB if you are using a formula. The rest of the metal oxide actually all basic oxide. That includes things like copper 2 oxide, iron 2 oxide, all this. Alright, as for the non-metal, okay, you have the acidic as well as the neutral. Neutral oxides are monoxide. Acidic one are a lot actually. They are either non-metal dioxide, trioxide, or even sometimes you get weird things like P2O5. Okay, also consider acidic oxide. Okay, so going back. Okay, so let's take a look. Okay, iron 2 oxide. Iron 2, you know is a metal, but is metal. Then it's not the Z one, right? Not zinc, aluminium, or lead. Then this one is amphoteric. Okay. Next one. Okay, lead 2 oxide. Okay, is the metal. And then happen to be the Z. Okay, so this is amphoteric. Sorry, just now that one, my mistakes, my apology. Sorry, it's metal, not Z, so it's basic. Yeah, right. Okay, next one. This one, non-metal. Nitrogen is non-metal. And then it's a monoxide. Right, monoxide. So this one is under neutral. Okay. Sulfur trioxide, non-metal, but not monoxide, right? It's not a monoxide. Okay. So this one would be acidic. Okay, next one. Same thing, non-metal, also not monoxide. Okay, non-metal, also not a monoxide. Okay, so this one also acidic. Okay, then again, non-metal but monoxide. So this one neutral. Okay, last one. This one, aluminium is metal, and then it's also the Z, right? Aluminium is A, right? So this is amphoteric. And last one, copper is a metal, but not the Z. So this one is basic. Okay. Okay. Right, this is question 15. Okay. Now let's go to the final question 16. Okay, so this is I think the O level questions from last year or last year. Okay, a pretty recent one, I would say. Let me see. Okay, so magnesium sulfate is a soluble salt prepared from an insoluble base and an acid. So magnesium hydroxide is a suitable one. Okay, so again it's soluble and then it's not spa, right? Okay, then you use adding excess solid to acid. Okay, so referring back to the summary booklet on page, yeah, correct, this one, page 11, right? So you have it's a soluble salt, not spa, so you use adding excess as mentioned by the question. Okay, so this is a base. Okay, suitable insoluble base, magnesium hydroxide. What is a base? Base is a oxide or a hydroxide, metal oxide or hydroxide. Okay, metal oxide or hydroxide. Right, okay, so they add excess to the acid, then make sure it's stirred and warm, and then the excess magnesium hydroxide is separated from your aqueous magnesium sulfate formed in stage 1. Okay, so stage 1 is like that. You have acid. Okay, then you throw in the magnesium hydroxide. Okay, Mg bracket OH2 right. Okay, then after that you can filter out, okay, the magnesium hydroxide. Okay, and then you leave it to dry lah. Okay, Okay, let's take a look. Okay, name the acid. Okay, so the second word always tells you about the acid. So this case, it will be sulfuric acid. Okay, just now was hydrochloric acid, now it's sulfuric acid. Okay, sulfate. Okay, you want a sulfate salt, you use sulfuric acid. Just now, the other question, if you look, I use a chloride salt, so I use hydrochloric acid. Yeah. Okay. Wait, let me go back. Okay. So chloride salt just now, right? You use hydrochloric acid. So try to see the pattern here. Then you have nitrate salt. So I use nitric acid, right? Sulfuric acid. Okay, so next thing, explain why your excess magnesium hydroxide is used in stage 1. Okay, so same reason just now as just now. Okay, is to make sure salt is not contaminated lah. Okay, you want to make sure the solid is the limiting reagent basically. Okay, if you learn already. Okay, so this one you make sure that the solid okay, so this one is a solid is always acting as the limiting reagent. Okay, so limiting reagent in all the reaction will be all used up one. Okay, for sure. Okay, so and sorry, not goodness, cancel. What am I talking? So sorry. Okay, so the excess one, you have to make sure okay, that the acid is limiting reagent, the solid is excess. Okay, it's like the bread and ham example we give in the notes okay, acid is limiting reagent. Okay, it will be completely used up. Okay, sure that all the sulfuric acid okay had reacted okay, so going on. Okay, so why is it stirred and warm is to increase the rate or what we call the speed of reaction. Okay, so this one I'll highlight more to you when we do the speed of reaction chapter. Okay, for now I'm not going to explain so much. So usually higher temperature, higher speed of reaction. Yeah, right. Okay, then name the method of separation used in stage 2. You should be able to see is filter. Filtration. This one should be quite easy. Then name the physical change that occurs to water in stage 3 when magnesium sulfate is crystallized. Okay, so you are just leaving it there. Okay, so the crystals form. Initially is a solution, so liquid to gas. So this one is basically evaporation over here. Right. Okay. Done. Alright. Okay. Then I think this is the end of this revision paper. All the best for your term checkpoint. If there's any question, please feel free to approach me. Yeah. On MS Teams or when I see you in person. Yeah. I'll be happy to answer you.